Hi friends, welcome back to my channel. Still on Power Machines N5. Today we are doing boiler efficiency. My name is Tsepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. So in boiler efficiency, we are looking at the heat transferred to the feed water in converting it to steam compared to the heat, to the total heat that is produced by the complete combustion of the fuel burned. So this is the heat energy that is being transferred to the feed water in converting it to steam, and this is the total heat that is being produced by the complete combustion of the fuel that we will be using. So MS, we have MS is the mass of the steam, and then we have H2. H2 is the enthalpy of the steam that will be formed. H1 is equals to HF at TF, which is the temperature of the feed water. And then we have MC, which is the mass of the coal, and then we have CV. CV is the calorific value, and it is given in kilojoules per kg. So this is the heat energy that the coal is producing, that the coal will produce per kg when it is spent, of course. And then in this topic we only have two formulas. It is the shortest topic in Power Machines N5. We have the formula for the efficiency, boiler efficiency, and then we have the second formula, which is the equivalent evaporation from and at 100 degrees. So I know some textbooks here, they are using 2258, but please, that value is not the correct value. 2257 is the correct value. Do not use the 2258. So that's everything that we need to know about boiler efficiency. From here we can attempt a question. So I have a question that you can do here with me, and then they say the following information were recorded during the testing of a steam boiler. Let's just write our data down. I will erase this. Hopefully you have copied. They say the following information were recorded during the test of a steam boiler. Mass of steam, we have mass of steam is equals to 6,600 kg per hour. And then they say the mass of coal, this is the mass of our coal, mass of coal is equals to 600 kg per hour. And then they say the pressure of a steam boiler. This is the pressure of the steam, which is 2000 kilopascal. And then we have the temperature of feed water entering the boiler. This is the temperature of feed water. TF is equals to 952 degrees Celsius. So let me just write it as TS, because when you are looking it in the steam table, you will have to look under the saturation temperature. That's why I will put it down as TS. The calorific value, CV, it's given in 32 megajoules per kg, but we will be using our calorific value in kilojoules, so we can just convert that into kilojoules. And then they tell us that the thermal efficiency is equals to 80%. So this is the information that they gave us. Everything is here, and then they say question number 1, 3.1. Calculate the following using the steam table. So we will be using the steam table as well here. The enthalpy of steam produced by the boiler. The enthalpy of steam, we will be using this formula. Efficiency is equals to M, that's the mass of steam, H2. This is what we are looking for. H2, the enthalpy of steam, minus H1 divided by mass of coal times the calorific value times 100. So what we are looking for, we are looking for H2 from here. We are looking for H2. So we have the mass of steam, we have the mass of coal, we have the calorific value. What we do not have is H1. But we know that H1 is equals to HF at the temperature, which is 95.2 degrees Celsius. So you just go to your steam table and look at the temperature, and under the column of the saturation temperature, look at this, look for this value, 95.2, and then when you find this value corresponding in that column, you look for the value of HF, and then I found that my value of HF is equals to 399 kilojoules per kg. So from this you can now make H2 the subject of the formula. Then H2, we make H2 the subject of the formula. H2 is equals to the boiler efficiency times mass of coal times calorific value, and then divided by the mass of steam times 100 plus H1. This is our H1, and then we substitute the mass, the efficiency we are given is 80%, and then the mass of coal, this is our mass, 600. The calorific value we are also given as 32,000, 32,000, and then we have the mass of steam, where this is our mass of steam, 6,600 times 100 plus 399 is equals to I calculated and got my answer as 276.273 kilojoules per kg. So that's our 3.1. We are done. The second question, they say calculate the dryness fraction of steam produced. So by looking at this question, we can tell that the steam that is being produced, the steam produced here, it's wet steam. Hence they are saying that we must calculate the dryness fraction. So we can just raise this and say 3.2, we know H wet is equals to HF plus X times, or we can just say HFG at 2000 kilopascal, 2000 kilopascal. So we'll use 2000 kilopascal in the steam table to get our values, the value for HF and the value for HFG. And then our H wet, we know that it is this one here, and then we can go ahead and make X the subject of the formula is equals to H wet minus our HF divided by HFG. HFG is equals to, our H wet is equals to 2,726.273 minus, I got my HF as 908, and then I got my HFG as 1889, and then calculate, I got my Dryness fraction is 0.963. And then we are done with our second question. Now our third question, they say calculate the quantity of heat absorbed by steam in the boiler. So calculate the quantity of heat absorbed by steam in the boiler. Remember we said from this formula here, from this formula, which is efficiency, okay, let me just erase this. From this formula, we said that M mass of steam, H2 minus H1. This is MC calorific value times 100. This is the heat energy of steam, and then this is the heat energy of the heat energy that is produced by the complete combustion. But now they are telling us to calculate the heat absorbed by the steam. This is what we are looking for, the heat energy of the steam. M of the FM steam S equals to, so this is 3.3. Mass of steam, we know that is 6,600. H2, which is the H wet, we know that it is, this is our value, it is 2,726.273 minus our H1, which we got as a 399, if I am not mistaken. 399. Remember, H1 is equals to HF at the temperature 95.2 degrees Celsius. And then we calculate and get our value as 15.36 times 10 to the power 6 kilojoules per hour. That's the end of our question, and then we can do the second question. A second question. Then I have another question here that we can do fast. Let's erase this. The second question, they say a boiler is to produce 170 kg of steam per minute at a pressure of 4 megapascal and a temperature of 300 degrees Celsius. The feed water temperature is 44.8 degrees Celsius. Then the thermal efficiency of the boiler is 71.3%, and the heat value of the coal is 33.8 megajoules per kg. With the aid of the steam table, calculate the following. So we have our data written down, and then we have our pressure given in megapascal, 4 megapascal, but we know that we are always using our pressure in kilopascal, so we can go ahead and convert this into kilopascal, which will be 4,000 kilopascal. And then our calorific value as well, we are given it in megajoules, but we want it in kilojoules, so we can also go and convert this into kilojoules per kg. And then our first question, 4.1, they say calculate the mass of coal. Calculate the mass of coal consumed per hour. So we go and write our formula, which is ms h2 minus h1 all by mass of coal times CV times 100. Since we are looking for the mass of coal, let's make it the subject of the formula. Mass of the coal, it's going to be mass of steam H2 minus H1 efficiency times CV times 100. So we can go ahead and substitute here our values. The mass of coal will be given by the mass of steam, which is 170. And then now we have H2. We know that H2 is the enthalpy of steam, the steam that is going to form. And by looking at this information from our previous video, we know that the only steam that will have a temperature that is above the saturation temperature, it's superheated steam. And then remember, we also said that if you do not have the specific heat capacity, since we do not have the specific heat capacity, which means we cannot use the formula that we know to calculate for the enthalpy of our superheated steam, because we cannot get the values. We do not know the value of our specific heat capacity. And then now, because we have our pressure and then we have our temperature, we can go to the steam table of superheated steam and then look for a pressure 4,000 and a temperature of 300. Where they meet, come and extract the value of H soup, which I got it as my H soup, I got it as 2936. And then we can come and put it where it belongs. Where is here? 2936 minus our H1. We know that our H1 is equals to HF at 44.8, and then I got my HF as 188. And then our efficiency is 71.3. Our calorific value is 33800, and then times 100, we get the value of our the mass of coal as 19.575 kilojoules kg per minute. But the question requires us to calculate the mass of coal consumed per hour. So we can come to this answer and then because it is in minute, times by 60, and then convert it into hours. So we have 1174.5 kg per hour. So do not leave your answer here, because this is not complete. This is what they are looking for, not this one. And then we have a question again, that question number 2, that say calculate the equivalent evaporation from and at 100 degrees Celsius. Then we can come and erase this. We know that the equation for equivalent evaporation is given by ms H2 minus H1 divided by MC times 257. Again, we put on our values. Our ms, it's 170, and our H2, we have our H2 here. Here is our H2. It's 2963 minus 1. Our H1 is 188. And then now, because I have used a value of the mass of steam in minute, that it's kg per minute, we must also use the mass of coal, that is in kg per minute. You can also use this value, but you will have to turn this into kg per hours. But since we have both values in kg per minute, let's just use this one. 19.575 times 2257, and then our answer is 10.678, and this is a fraction, so there are no SI unit. There is no SI unit for equivalent evaporation. So that's basically the end of boiler efficiency. Hope this lesson will be of help to you. Please don't forget to comment below. Tell me what you think about today's lesson. Don't forget to subscribe to my channel, like this video, and share it with your friends. From me to you, I will see you in the next lesson. My name is Tshepo. Ciao.